Oh,
Wait, was that?
we already covered this particular slide from yesterday.
You mean
We're down to 28.
Actually, it wasn't yesterday, it was 2 days ago.
2 days ago. I'm gonna keep referencing it as yesterday, even though
We did this
it
one.
was 2 days ago. Yeah, I know.
Not
I know.
yesterday.
I know.
It was not yesterday.
I said 2 days ago.
Just let him say yesterday.
All right, remember DOT3 brake fluid, okay? Special fluid that's going to obviously allow us to not freeze in the wintertime and also, more importantly, not boil at 212 degrees Fahrenheit. There are various different properties that this brake fluid has to have beyond just its ability or inability to boil and go from a liquid into a gas. One of those properties is its ability to absorb water, okay? The scientific principle for that is called hygroscopic.
Yeah, I got that right.
Hygroscopic, okay? It acts as a desiccant or a drying agent. You know those little silicone packets that you find in some packages that you order?
Yeah.
Or like beef
Beef
jerky,
jerky.
right? Why are those there? That's a desiccant. They're put that in the packaging so that way if there's any moisture in the air in the packaging, it absorbs that instead of going into your product, right? Because if I order or I buy a bag of beef jerky, I don't want soggy beef jerky. I want dried, dehydrated beef jerky. So the silicone packet there is to basically add that in, okay? Or take away the moisture in that area. Okay, same thing with our brake fluid. Now, here's a fun little tip, right? Water that is absorbed in the brake fluid, that is a contamination. It's a contaminant, okay? We don't want it in there even though it does absorb it, which means we have to periodically go in and actually flush out or exchange the brake fluid with fresh brake fluid. Yeah?
This is a question I've had for you. What's the difference between DOT 2 and 5?
Well, there isn't DOT 2.
Well, DOT 3, I guess. Or like a low dot versus
Sure.
a very high one.
So without getting into too specifics, DOT 5 is a much more silicone or silicate-based brake fluid. It has a much higher boiling point than a DOT 3. DOT 5 you're not going to find in any vehicle that's on the road. Okay, but DOT 5 is pretty exclusive for race cars.
Unless
Okay.
someone was racing on the road.
Because you would need special brake components in order to be able to use this. Otherwise, if you use DOT 5 in a normal DOT 3 system, it will contaminate and damage your brake parts, which means they ain't working
You have to
right.
use the right dot
Okay.
with the right system.
Absolutely, okay. And we'll talk about how you can identify which type of brake fluid that you're going to use on the vehicle. It's not overly complicated. But again, kind of the general rule of thumb is, at least in years past, if it's an American-made manufacturer, right, it's usually generally using a DOT 3. If it's more European-centric type manufacturer, you're probably going to end up seeing a DOT 4.
Wait, why is that though?
Okay, it's just different regulations. So in America, we have laws that say these are the requirements. In Europe, they say these are the requirements.
Does that mean that European cars are faster?
No, it doesn't mean they're necessarily faster. It just means that
No, European
their
cars beat
brake
mine, okay.
regulations or laws that the manufacturer has to comply with are different. Now, we are starting to see some American manufacturers transition and use DOT 4. So just throwing that out there. And again, really the only big difference between DOT 3 and DOT 4 is DOT 4 does have a elevated boiling point than DOT 3 is. Okay. The dramatic difference is when you start getting to DOT 5.
Never mind. I answered my own question.
Good. All right, so anyways, we have to absorb water. It has to hold its viscosity. Remember, viscosity is its ability to flow.
Yep.
Okay, so again, under extreme conditions, both cold and hot, it has to flow. Have a high boiling point, obviously, because we do not want to vaporize our liquid that we're transmitting through our hydraulic system. We can't be corrosive, right? We don't want our internal brake lines or calipers or brake components to rust, but it's going to if we're absorbing water. So again, that's why we have to periodically change out our fluid. Has to lubricate the brake parts, and again, low freezing point if you live in northern climates like Wisconsin. Oops. All right, we also covered, I think, this This one? This is where we left off?
No.
I don't. We didn't probably spend a ton of time on
I
this
think
one.
this is the last one we got.
Yeah.
This is it.
All right. When the driver depresses the brake pedal. So the first place that you are going to interact with the braking system is the brake pedal itself. Okay. Basically, what's going to end up happening is you as a human being are not going to be able to generate the force to be able to actually cause the vehicle to slow down and stop. Okay, you're not strong enough. Okay. So what we need to do is we need to incorporate mechanical devices into our braking system that is going to leverage that and amplify the force that's going to be pushed onto the hydraulic system so it is transferred to the brakes in order to generate the forces and friction necessary in order to slow and stop the vehicle. The first thing that we do is incorporate the brake pedal as a lever. Okay, you guys, simple mechanical tools. Okay, so if my foot is going to be pressed on this thing, you guys like this? Okay, if I'm pushing on this, it's going down. The pivot point is up here, right? And this is a lever. So now I can actually multiply the force that I'm pushing into the brake system into this push rod.
By leverage.
Okay, by leverage, through a lever. Okay, so that's the first thing we're doing right off the bat. All right, we're creating a greater force than what we're actually pushing on. Now, force is applied to the master cylinder. So in this case, can I get a different color here? Let's go green. Right? Here's my master cylinder. There we go. I don't know if that shows up too great in the back. But I need to come in here. I need to put a force on this hydraulic fluid, okay, through these pistons. And these pistons are then going to push that force through the brake lines to the four corners of the car. Okay? And again, because hydraulic systems are transferring that force throughout the system, it's going to go undiminished to each corner of the car, which is kind of fun. Okay. So this is where it starts, brake pedal. All right, disc brakes are usually power assisted since they are not self-energizing like drum brakes. I'm not going to get into the idea behind this, but basically, if I had drum brakes and I hit the brakes, the shoes that are on the inside that are creating the friction as the wheel is rolling, it actually situates itself to the one shoe pushes against the other shoe, so it essentially generates its own force through the mechanisms that are involved there. Okay, so I don't need assistance or a power assist in order to generate that friction. Okay. On disc brakes, however, because of how I'm clamping and creating the friction by basically grabbing the rotor, okay, I can't generate enough force with the leverage of the pedal alone, pushing into the master cylinder. So I need some way to boost that force that's being applied, okay? Or I should say, allow me as a weaker person to be able to enhance that more. Okay, this is where our vacuum-powered brake booster is going to come into play. All right, and this is another part on our tool.
Wait, can you go back?
This screen's going to be the same information.
Well, hello. Actually, it's not.
So the vacuum booster is a large diaphragm device located between the master cylinder and the brake pedal. Okay, it's the meat in the sandwich, if you will. The cheese in the grilled cheese. Brake pedal, master cylinder. So what ends up happening is as I'm pushing on the brake pedal, it's going to push that push rod in. The push rod is going to be going through here. Okay, so I'm putting a force into this. There's a diaphragm in here. Okay, and that's going to assist pushing it into the master cylinder, which is right there. There's my master cylinder.
I thought diaphragms made noise.
No.
I got a
Okay.
turkey call and it's called a diaphragm.
The reason why this is a diaphragm here is because we're actually using the power of atmospheric pressure in order to push or assist that push rod going into the master cylinder. Okay? By the way, if you're writing everything down on this, you're doing your notes wrong. Okay? Just throw that out there. You do not need to write word for word everything that's on the screen. You need to summarize and write down as quickly as possible. And then start paying attention to what I'm saying. Okay? So anyways, what ends up happening is this. On this side of my vacuum booster, I create a vacuum. Okay, suck out all the air. Okay, on this side of the vacuum, I suck out all the air. Okay, so it's a vacuum on both sides of this diaphragm. As soon as I start pushing on that brake pedal, what ends up happening is this side of my brake booster essentially opens up. Again, I'm not going to get into the full details here. Allowing atmospheric pressure to go into this side, and because this pressure is higher than this side, okay, that then pushes on the diaphragm, which is then hooked up to the push rod, and that is allowing us to assist the push rod putting it into the master cylinder. Okay, so just throwing that out there. Yeah. All right, power brakes use either engine vacuum to create that vacuum inside the diaphragm, or in some cases we might actually see the power steering system develop pressure, right? So the power steering pump is generating hydraulic fluid to be able to assist the turning, but then after it's doing that, it's also then going to our brake booster and then adding an assist there as well through its hydraulic pressure to allow the driver to be able to easily push on that brake pedal to generate the force required to push into the master cylinder to develop the hydraulic pressure. Okay, so kind of fun on that end. All right, the master cylinder. So again, we went from brake pedal as a lever through a vacuum booster to assist the person pressing on the brake pedal again to generate the force necessary to put into the master cylinder. The master cylinder is nowadays a tandem. Okay, we got two master cylinders or two reservoirs in the one master cylinder. Okay, these are separate hydraulic circuits. Okay, but we have one push rod that's going in here. So what ends up happening then is, as we're doing pushing on the brake pedal, again, master cylinder is generating the hydraulic pressure that is then going to travel through the brake lines undiminished into the different four corners of the vehicle. Okay, we'll talk about why we have a tandem system instead of just a singular system, but it has to do with safety. Okay. All right, a metering or hold-off valve. Again, this is another component inside of our brake system. Because as you have been taught, 60 to 70% of my braking force occurs in the front wheels, 30 to 40% occurs in the rear wheels. Okay? If I hit the brake pedal, I'm going to have essentially an equal amount of force going to all four wheels. I don't want that. Okay? At the same point in time, I need to understand that the distance between my master cylinder and my front wheels is a shorter distance than to the master cylinder to the rear wheels. So it has a longer distance to travel. Okay? Which means I need to make sure that all four wheels are stopping at the same time. So in this case, I need to delay the brakes in the front from locking up until the rear brakes start to engage. So my meter or hold-off valve is essentially putting a delay on my front brakes from engaging until my rear system builds up the sufficient amount of pressure necessary to start engaging those brakes. Then we can start engaging the front brakes. So that way all four wheels are enacting at the same time. Okay, but that's called a metering or hold-off valve. A proportioning or balance valve, again getting back into this, is going to be where we are sending equal braking force front to rear. Again, 60 to 70% of my braking force is going in the front. I probably want 60 to 70% of my force going up to the front because I need to appropriately send that to where it needs it the most. Okay? But again, all of this is kind of set up by the manufacturer specifically so that way it maximizes the tire grip in order to slow and stop the vehicle as quickly as possible. Now, the fun part is, again, on race cars, I can mechanically change the amount of percentage of the force going to my front wheels as compared to my rear wheels, which tends to help rotate the car and slow the car down faster and whatnot, because again, my goal on a racetrack is to go as fast as humanly possible. Okay? On a street, right, my goal is to have as much grip as possible in order to slow down and stop in emergency situations or whatnot while driving. And I'm not going to be driving at such extreme speeds on the road as I would on the a race car on a track. But it's kind of interesting. Okay. Again, here's just kind of a dissection of a master cylinder again. All right, brake systems do have obviously a stoplight switch. So we do have some electrical components here. Typically speaking, this brake light, the stoplight switch is going to be turning on your brake lights. It's also going to be hooked up to your brake pedal. So as soon as you start engaging that, that switch is turned on, allows electricity to flow through it, which then illuminates the tail lights or your brake lights. Okay. You're also going to see a low fluid switch typically in your brake master cylinder, as highlighted here in magenta. This is monitoring how much brake fluid you have in the reservoir. Obviously, if you have a low level, it should alert you through a light on your dashboard. It might even have a pressure differential switch to warn if there is a leak in the system, right? Hey, FYI, your brakes have a leak, you're not going to be able to stop. Your parking brake is also going to have a switch. So if your parking brake is engaged, it's going to stay illuminated so that way you don't drive off with your parking brake on, which, by the way, people have done before, right?
Very common.
Probably more common than you think. Keep in mind that the horsepower in your engine is going to have more enough power to be able to overcome the parking brake, right? Your parking brake is just designed to prevent the wheels from spinning when stationary, which is, it doesn't take much effort to do that, which is always fun and entertaining because if you're driving around with your parking brake on, it's going to wear out that parking brake very quickly. Can generate a lot of heat too, because a lot of friction's happening. All right, vehicles may have more than one brake warning light in your instrument cluster. Okay, so the big takeaway for this particular idea is the color and the type of light that is associated with our braking system. Okay, so if I have a red warning light, typically that's an indication of a problem, right, in our regular braking system. Could be low fluid, okay, or your parking brake is applied. An orange or amber light is tied into your anti-lock braking system, your ABS. Yellow light, that's going to typically let the driver know that the wheels are slipping because of poor road conditions.
Or you're doing a burnout.
Sure, but your tires are slipping when you're doing a burnout, so that's how that works. Okay, keep in mind that when you key on the car, okay, when you key on your car, a bunch of these lights are going to light up on your dash. It does not mean you have a problem, but what ends up happening is when you key the car on, it's doing a light bulb check. Okay, you should see these illuminated. As soon as you start the car, all of them should de-illuminate, turn off.
After a second.
Okay, right. If you key it on and it does not illuminate, it's telling you that the light bulb is burnt out and it needs to be addressed. so that way it can communicate with you if you do have a problem, okay? Kind of the whole old adage is, well, I got a check engine light. How do I get rid of it? I take some black electrical tape and just cover it up.
No, you get a code reader and clear it.
Clearly,
Clear it, are you incompetent?
okay? The idea is that don't ignore these lights. They do mean something, and they're trying to let you know things are happening on your vehicle.
No.
Okay.
They're just annoying.
They are annoying. That's their they're designed to be annoying.
Nah.
Good old Sharpie will fix
Okay.
everything.
But anyways, again, real quick, red light,
I have a code reader
orange
in my
light,
car.
yellow light. What do those colors mean? What are they associated with?
Red, bad,
Okay.
orange, look up, yellow.
Yeah.
Check engine.
You'll
color.
notice that there's no green lights up here. Okay.
They're on the road.
Check engine should be.
Yeah, they're on the road.
Check engine shouldn't even be there. You're fine.
Yeah, totally.
Someday.
These are some examples, by the way. I don't know if you want to draw some of these. Each manufacturer kind of has a small twist on what these might look like. They're trying to be universal. But, right, hey, my vehicle's slipping. I have no traction. Yellow light. Right, my ABS, orange light's going on. Okay. Might have a red light here. I know you can't really see the color difference on this. Parking brake might be on. Or it could be that we have low fluid in our master cylinder. Okay. All right, brake lines. Brake lines are made out of a double wall steel tubing, typically steel. Here's a brake line right here. Okay, this is not steel.
It's copper.
It's not copper. Okay, this particular brake line is more expensive than your steel stuff, but it's easier to work with. It's called NICOP.
I was pretty close with copper.
Kind of. It was half the equation. Okay, this is a nickel copper alloy.
Yeah, so
Okay, which means that it's easy to bend and form into place. So if I want to replace my brake lines, and I'm not very skilled, right? I probably want to buy this stuff right here. Okay, again, a little bit more expensive than our steel line, and it's easier to work with. So typically I buy this so that way in Auto 2 when we go to practice making our own brake lines, this is more forgiving. It usually allows us to make it successfully more often than not. Once you develop the skills and have used the tools before, then you can go up to the cheaper steel line. But the idea behind this is it's we'll probably get into this a little bit later on, but we do not want to kink this line.
because it'll stay kinked.
Okay, because it's going to stay kinked, and that means it's a restriction on our hydraulic system on our brakes, which means our brakes are not going to be performing as intended. Okay,
So you just have to bend it like.
what you have to be very careful when bending this. You can't just take it and go, yeah, okay, that's good enough. There's special tools that allow you to bend this without kinking it. And then but the ends have to be formed in a very particular way, so that way when we bolt it into our components, it allows for free hydraulic fluid
A single
movement.
flare, a double
Okay.
flare, or a bubble flare?
Typically speaking, we're looking at a double flare or a bubble flare. Okay. Again, this is kind of distinguished between what type of vehicle you're driving. Okay, again, most American manufacturers are going to specify a double flare, where you're probably going to see a bubble flare on more European vehicles. Okay, and that's just because of the standards. In America, we do SAE standards. In Europe, they use an ISO standard. Okay, International Standards Organization. So that's why they would use a bubble flare over there. But it's very important that if you are to go to make your own brake line, you know which flare is required and you don't make the wrong one. Because if you make the wrong one, it's not going to fit. You're going to have leaks. Your brakes aren't going to work very well. Okay? So that it's an art form, and the problem is as you're making this brake line, as you're bending it, you get one kink in it, you got to throw the whole thing out,
How much
start
is, like,
over.
what is that?
I don't
5 feet?
know. Maybe
Please tell me they're a little cheap.
not as cheap as you think. You make too many mistakes. Now, granted, there are ways that you can patch stuff in, but it can get ugly. Okay.
Okay.
But this is our standard hard brake line. Okay.
How much would that cost?
This
For 5 feet?
I have no idea.
$20.
I forget what I paid for it. I got 20 feet upstairs maybe for like $40.
Oh,
Okay. That was again, that was purchased a while ago.
How much
Anyways,
is it?
this stuff here doesn't bend. It's your main brake line. However, as you are aware, my caliper is attached to my suspension system, right? Wheel's gonna be going up and down. It's gonna be rotating. This doesn't do that. It's stiff. So what do we run from this out to my brake line? Well, we got flexible rubber hoses that are reinforced. Okay. That's going to kind of finish that connection. Okay. And these rubber hoses are again reinforced. They're going to be able to handle the hydraulic pressure that's going to be developed in our brake lines. But we can also understand that these can be damaged and actually damaged more easily potentially than our solid brake line. Okay? So this is one of the precautions that we have to take immediately when we're working on our brakes. We have to make sure that our caliper, when we detach it from our brakes, is not being hung by these rubber hoses. It's not meant to support that weight. Okay? And you can and will damage it, which means we might have some bulging or expansion from the fluid. Or internally damaged to the point where you can't see the damage. All right, we mentioned previously that we have a tandem master cylinder. It's a dual chamber master cylinder. So as I'm pushing my brake pedal and I'm developing the force that goes into the hydraulic system, okay, I got two pistons pushing on two different circuits. The reason why we have two different circuits is a protection against leaks or brake failure. Okay, so typically we're going to have one circuit have two tires on it, and then the other circuit has the other two tires on it. So even if one circuit develops a leak, I'm still going to have full hydraulic pressure and the ability to slow or stop in the other circuit. It's not ideal because I'm only running two wheels, stopping with two tires instead of four, but it still allows you to at least slow down, stop, brake without hurting yourself, injuring other people, or damaging the car.
Would
Okay?
you, what, like, I don't know how to say this, what's better, diagonal or longitude?
Yeah, you beat me to it. I was going to get to that here in a second. That's a good question, though. Okay? Now, the two
I think
different types
diagonal.
of circuits that we're going to see on most vehicles. Either your circuit is divided up longitudinally
I don't like that word.
or diagonally. Okay? Now, let's just think about this for a second. How much braking force am I generating in my front wheels in comparison to my rear wheels?
60 to 70, 30 to 40.
Okay? 60 to 70 in my front, 30 to 40 in my rear. Okay? So which one of these systems is going to be better?
Diagonal,
What are you pointing to?
that side.
Oh. Okay. Cool.
Like a squirrel.
Yeah, I'm just like pointing on one. So which one's better?
Diagonal.
Diagonal? Why?
Because then if you have a brake line and or you have a leak, at least you're braking some in the front and some in the back.
Yep.
Yep.
Okay, diagonal is definitely the better option because regardless of which circuit's breaking or broken or leaking, I'm going to at least have one front wheel
That's braking.
and one rear wheel. Okay? Now, longitudinal is an older type of system. We don't see them too often nowadays, although they still do exist.
You could either
If I have a leak in my front circuit,
You're gonna cross.
that means I only have a 30 to 40% force to slow me down and stop. Will I still stop and slow down? Absolutely.
Eventually.
It's going to take longer though. It's going to take more space. Okay? Yep. Where on here I can at least slow down with less time, less space. Okay? Now, this is very important that you are able to identify this one or this one. Because if you were to go to bleed your brakes or exchange out your brake fluid, there's a sequence of which tires or which spaces you do first, second, third, and fourth. There's an order to it. Okay? Now on the lab sheet, when you guys go out in the shop, you are going to be required to inform me, I believe, hey, what's the brake bleeding procedure? Which one do you start first, second, third, and fourth? On Identifix, it'll tell you that, but then it also, you can figure out, okay, I start here and I go here. I go here and then I go here. Well, if I draw diagonal lines in terms of that sequence, guess what the layout is? Diagonal. If it asks me to go do the two back ones first and then do the two front ones first, that tells you it's longitudinally split.
So you're saying front, left, back, right, and then front, right, back, left.
So typically speaking, the order, or at least the rule that you want to follow, right, old school rule, is you always go to the tire furthest away from the master cylinder. That's typically your rear passenger tire. Then you would do your rear driver's side tire. Then you do your front passenger, and then you would end at your front driver's side, because that's closest to the master cylinder. On a diagonal system, that's not true. Okay? You would start here, right, furthest away, then you would go up here next, because that's part of the same circuit. Then you would go here,
Ooh.
rear driver's side, and then end here, because that's on the same circuit. Okay, so these two are connected, these two are connected, these two are connected, these two are connected. So that's I'm not having you guys do any brake bleeding for the lab, but I'm just saying
If you would to.
there's a reason to why you would do it in this way. Okay, it's due to the fact that you have two different hydraulic circuits, and you need to bleed it each circuit individually or independently. Okay, we're going to end on this slide. When fluid pressure is applied to a brake caliper, piston moves the pads against the rotor. Again, we're going to get more into this detailed information probably next week when we get into disc brakes. But just note this. I push on the brake pedal. There's a lever. I'm creating force. It goes through a vacuum booster. Okay, assists me generating more force. Goes into the master cylinder. The master cylinder is the reservoir for our brake fluid. That brake fluid then is traveling through the brake lines. Okay, what's its end destination? That force, undiminished, is going to be pushing on the back of my piston out here on my caliper. Okay, so here's my piston. Brake fluid's coming in here. The force, it's going to then push on that piston, which is going to go on my brake pad, and then it's going to generate that friction. Okay? That's kind of the idea behind the whole situation here. And you can actually see here the piston on my caliper. Okay? Things along those lines. Okay, don't pack up your notes yet. Don't pack up your notes yet.
What if we already did it?
Then bring them back out.
What if I already did my 3 questions?
I doubt. But
Yes.
anyways, we're going to give you guys the last 4 minutes of class. This is what I want you to do. 3 questions from today. Go back and look at your Monday notes as well. Are there any questions that pop up now based off of what we talked about on Monday, based off of what we may potentially talked about today? Again, these questions are not essential questions. They're just things that you're curious about. Hey, you went through this too fast. Don't understand this. Don't get this. Hey, what about this? Right? Maybe you know maybe a little bit of additional information that we haven't talked about specifically yet. Okay? Right? So like one of my questions is, hey, Mr. Getsky, how many pistons do calipers have? How much can they have? If I'm pushing this piston on this brake pad, what's happening to the other brake pad?
Ooh, sneak peek at tomorrow.
Uh-oh. I don't want to show you the sneak peek. Just kidding. It's just this stuff. All right, anyways, we're going to, oh my goodness, where am I at? Here we are. End the recording here.
And see everybody later. Look, I'm like